Welcome to this talk today. We're talking about Introduction to MLNET 1.0. And this is brand new technology. If you're a .NET developer or if you're working in the area of data science and you're interested about how to integrate data science with .NET applications, then this is the talk for you. The role I have, my name is Mark Tabladillo. I am a cloud solution architect at Microsoft. I work in the US CTO Customer Success Unit, and I am a data scientist. And you'll find my information there on the bottom, listed MarkTabNet. So what we're going to do is we're going to first look at the community evidence. I think that will be the way to evaluate how this technology is tracking. Of course, it is brand new. 1.0 was just released months ago, and this will be the way that .NET can connect or have some assets related to data science. There's a lot of open source momentum. That .NET machine learning is on GitHub, where you can find out more about this technology and also some of the demos that I'm going to be doing today. And you can see some of the downloads, commits, pull requests, and contributors. Obviously not the exact largest of projects in open source, but certainly .NET is entirely open source these days, and this technology is also part of that the open source contribution. Now, as we're starting today, I'm going to go ahead and launch this poll, and you will see this poll here, and it's going to ask you what your goals are today in attending this seminar. So feel free to mark one or all of the responses, and then I will show the poll results. So we'll let that poll have a few more seconds here to go. And I'm seeing right now we have over 100 attendees today, so glad to have so many people attending. Okay, and then I'll show the results here. And you'll see kind of the idea here. We have a majority of the audience, maybe today with a 75% response rate, are interested in implementing ML.NET soon in a solution. And just by coincidence, I happen to be contacted by a partner, and in my role, I do work with partners of Microsoft, and they are working with a state government to implement a solution, and they're very interested in using this technology. And I said, well, by coincidence, I happen to be doing these presentations. And by the way, this specific talk is the first of 4 different talks. They will all have different demos, but they're all going to be around ML.NET. And I will be recording these presentations. They will be shared on YouTube, and the slides will be available. But right after this hour, there's going to be another talk on AutoML and focused on a slightly different topic. So feel free to attend that second one. Anyway, this partner says that they have a group of 300 consultants, and many of them are interested now. They're already .NET developers of so many years, and they're interested now in using this new technology in this solution for this state government. So we're going to have a conversation later on today and maybe in the coming weeks. But there is a need now to put ML, put data science into solutions that already exist or extend solutions that exist, and then also maybe work with Azure. And that's the interest that a lot of people have right now. Okay. All right. Again, this deck will be available after the presentation, after I get it published and produced. We have a number of customers now who have used ML.NET, and these are some of them here. And here's a claim: ML.NET made it straightforward to leverage our existing .NET and C# skills and software assets to add machine learning capabilities into the application. Deployed on Azure, integration of machine learning models was easy and straightforward. And of course, that's coming from Evolution Software. And of course, you do see we're also using it internally here in Microsoft and Power BI and Bing and in Office. So we are using this technology for some of our own products. There's a link here, and you'll be able to see that later in the deck. ML.NET Customer Showcase, and where you can just look on search engine and find this list. But we have different testimonials of teams and what they are doing with ML.NET. We'd love to have more customers show up here. So if you are a Microsoft partner, or if you are at Microsoft and working with a customer and can share that story, would love to see what is your experience, what is your use case, where do you think this technology has value. Many people would love to know that story. Let's go over some of the features here of ML.NET. Of course, .NET is your platform, quote unquote, for building anything. And of course, we see desktop, web, cloud, mobile, gaming. And on the right side now, we're adding IoT and machine learning. What is machine learning? Again, this is maybe a function, which is what many people in the development world will understand. What is a function? And a goal. Goal is this a face? And then here is another function. What should the price of a shirt be? You know, how is it described? How is it used? In fact, even who's it marketed to might be part of the question. And these are the types of questions that machine learning can help answer. And machine learning, what does it do? It creates a model, which is a function. A function is an approximation of reality. And it uses data that is used to train the model. And I noticed here on the example, and again, I didn't make these slides, but I love the people who did, but they put face, those are examples of faces. This is not a face, but this might be the face of marketing. I don't know. And then the animals, I mean, that's the animal face. So I don't know. I mean, I love animals, and anyway, animals got ripped off here. But anyway, the point of this model here is to determine a human face versus what is not a human face. So that would be an example of what can be done with machine learning. And the hard part here, and even with face detection, this has been a type of challenge that programmers have historically tried to solve. I'm not going to give the evidence today, but it's something you can research about what approaches people took to solve this challenge. And only recently now, deep learning, have we seen some breakthroughs that have the accuracy rate that have some practical application. MLNet 1.0 was announced at Build 2019. And by the way, Build is Microsoft's developer conference. So if you are a developer and you don't know anything about Build, look up Build. There's so many videos and assets online related to Build, and you can go learn more about what Microsoft has for developers. But it's a machine learning framework for building custom ML models. We have some automated ML and tools. Okay, we're going to be talking about automated ML in the next session. It's proven at scale internally. Again, Microsoft's using this in Azure, Office, Windows. It's extensible, so we see the ability to use TensorFlow, Onyx, and Infer.NET, and then cross-platform, of course, and that's so important now. We're not just a Windows world, we are a Linux world, iOS, Android, and we want these technologies to be available on many platforms. What are some of the things we can do with MLNet? This is a list, and this list of 9 things is on GitHub. We are going to be looking at some of them today in the demos, but you'll be able to see this later in the slides. So know that you can do things like image classification, sentiment analysis, price prediction. There's actual examples that you can run and start trying now. Now, here are the 3 concepts, which might show up in future certification exams. All right, first thing you need is data. And right here on the bottom, you have comment text and you have sentiment. So this is done for sentiment analysis. And this comment here, wow, love this place, has a sentiment of 1, meaning a binary positive. Crust is not good, which is like a negative. Not tasty and the texture was just nasty, that's a negative. Selection on the menu was great, that's a positive. Okay, so that's how we make these simple ideas about text and sentiment, and that this slide is based on an actual data set that's used in the examples. All right, so the data's first, but then you have the transformer. Now what happens for the transformer is data goes in and data comes out. So all the transformer is doing is some sort of data manipulation between there. Where you do that, you could do that at the relational database, depends what the problem is. We're not talking about optimizing right now, but this is how the concepts work for ML.NET. So what happens here in the text might start as regular string on the left, and then they get featureized into numbers on the right. And so numbers are what's typically needed for machine learning models, and that's why there is some sort of remapping that happens. And then third idea is estimators. So we have data, transformer, and then estimators. And note the difference here, data goes in, transformer comes out. So data comes in, and then you get something at the end here, and that would be the model that would come out of that process. So the estimator here is used for that purpose. And of course, this is the sentiment analysis example here. Those are the features, which are the input. These are the labels, which are the output. Now, right now, this is just a string feature going in. So this is a text analysis. And then, the question there is this a positive comment, yes or no? So now we're going to jump right into the demos. And what I am running, let me show my screen. And I'll make sure that that is showing, and that indeed it is showing. So what I'm running is called our deep learning virtual machine. It's a virtual machine that runs on Azure. And if I go here to Task Manager, you'll see an idea of how large this machine is. This is an Intel Xeon CPU E5 V3 and memory 112 gigabytes of memory. So it's a fairly large machine. And well, actually, it's kind of the medium size. There was also an NC24. There's an NC6, 12, and 24 that I saw, and this is the 12. So this machine comes already preloaded with a lot of software, which you can see here. Now, I did make some changes. What I did is this machine was already preloaded with Visual Studio 2017, and I put 2019 in here. I did that one thing. And the second thing I did was I updated Power BI Desktop just for whether I'm going to use it. I may use it in tomorrow's presentations, the same machine. So that's why I updated that. So let's go straight to the code. And in fact, I'm going to open the second window. So we got Visual Studio 2019 here with our new logo. And what I did is I cloned the repo that has examples of ML.NET. And it was as easy as just putting in the website from where it's coming from. Now, one thing I had to do in this case, let's see if I have my, oh, it lost my links. Okay, I'm going to have to get the link again. Sorry about that. You lost my link. Why'd you lose my link? Okay, so let me show first the GitHub. So this is the GitHub .NET Machine Learning, which is where these examples that I'm showing today are. And it shows a little bit there about machine learning for .NET. It says ML.NET runs on Windows, Linux, and Mac OS using .NET Core, or on Windows using .NET Framework. 64-bit is supported on all platforms. 32-bit is supported on Windows, except for TensorFlow, LightGBM, and Onyx related functionality. So there's some technical details if you are that developer. And what I'm going to do is go straight to the examples repo of samples. And so here's the MLNET samples. And this is the samples that I am going to be showing right now. They come straight from GitHub, and this repo is the one that I cloned to be able to show the demo today. So we're going to have sentiment analysis, spam detection. We see some of what the answers are here about what these examples are. So let me go straight back to Visual Studio. You'll see on the right side is the complete repo, which got cloned into my directory here on this virtual machine. And what I'm going to do is open this samples under C#. So we'll start with the C#. And I'm going to start with the first example here, which is the sentiment analysis. And notice that they are in C# and F#. And I'm going to call it F# as a excellent way to consider programming. If you're doing algorithm development or mathematical manipulation and you are .NET, then you need to look at F# if you don't know about it. And again, that's not a focus of today's talk, but I will provide a link for you to look at F# later on. So again, we're looking at the sentiment analysis. You'll see it, all the examples here are on this drop-down box, and they're ready to run. So they're already ready here. The sentiment analysis console app, I'm going to go to that one, and I'm just going to press run. So let's just press run first. It may take a little bit of setup time. So right now I can see that it's building delay until bar and packages finished restoring. So right now it's getting set up for the first run. So let's let that set up. And while I'm going to show what the example is by going here and going to the C#. So let's describe what this is. So this is going to be the sentiment analysis. It's going to have it's a text analysis. It's going to have 0 as a nice or 1 as a toxic or negative. And you say, well, when would people actually do that? Well, let's see, the example came up. Let's see. So let me go to the screen because we've got the live screen coming up right now. It's running as a console app here, just as far as the development. And what I think is really cool is you look on the right side here. It's got these diagnostic tools, and of course it's already done. But let's start on the right side. It's got these diagnostic tools that show how much process memory is used and how much CPU. And I'm noticing that I think that's really cool. But I also like to bring up Task Manager, which shows the CPU usage. And of course you can see that during the processing of this particular sample, and it just built right now. The model just trained and also did a prediction. And you can see what the pattern is with the usage, and then also how much memory. Now 112, and I found in all these examples, really they're not using the memory, but they are using the CPU. So going back to here, the example, so let me just read what this says. These are the metrics for the trainer here, and it's got the accuracy, area under the curve, area under precision recall curve, F1 score, log loss, and a lot of other metrics. It saved a model, and then it did a prediction. Now, the prediction is based on this text. The text, and this is text actually I put, so this, if you run the example from the repo, you're not going to get this text because I changed it. But I said, leave me alone, I'm busy. So prediction is, this is a non-toxic sentiment. And it gives a probability, and the probability is 0.14. And so then it's making a specific prediction based on text here. And so that's what it did. And then it says, hit any key to exit. Now, one thing I noticed here is that, let me make sure here. It's not really any key. There's actually a bug here because, any key to me means any key. And I always use spacebar, and I'm wondering, I keep hitting spacebar. How come this is not exiting? So it's because it should have said hit enter key to exit, because it's not going to do that until I hit the enter key. And then this second one says press any key, and it really does mean any key. I can press spacebar and it will close. All right, so if one of you wants to report that, then you can become a contributor to this project. So moving on, let me go to the code, and I want to show the code here. You'll see this is the sentiment analysis on the right side. And then the program here, let me just touch that. Okay, so right here, you see this is all the code. And now right now when I open it, the lines are compacted. So you see right here on the left, it goes from line 24 to line 79. So that's where you have to press the plus button to expand it. And I'm just going to show some of it here, but you can see in the beginning what it's doing is it's building first of all, framework of where the data is, and the data comes with the sample. So you don't have to process that for yourself or do any cleaning, but it's already there. So the data here, and then it does a training and test split, and then it does a featurizing text, because it's going to take the text and turn it into numbers, determine what the label and the features are. Then the training model, that's that, does the transform, because remember I used the words, remember the words earlier, data, transform, estimator. And the estimator here is built with the evaluation. You can see when I hover over it, it will also show me what class this information is coming from. So if you wanted to look up the class, you could do that. Where do I look up classes? I like going to the object browser here. And I always remember object browser because anytime I've done C# programming and I don't know, what the class structure is, you want to make sure that you have the ability to look at that, using something like this object browser. So that's what will show that technology. Okay, so this is, if you see down here, line 64, this is where I put in text saying, leave me alone, I'm busy. Now I'm going to change this, and again, I'm just going to do this live. So I'm going to do I'm going to type in the word, right now I'm really angry, and then we're going to run it again. So let's do a do-over. Hopefully this is not going to take as long as the first time, but the way this program is written, it will go ahead and retrain based on what the data is and then score it. I did not try to make it do anything bad. So actually right now I'm really angry came up with non-toxic sentiment. That's non-toxic. So, again, this is the way this particular program works. Let me see if I can press stop. And does it stop that? No, it doesn't. Actually, you still have to put the key to close the window. Okay, so that's interesting. And then, so you could just try different text snippets here and see what the sentiment is. That is a bad idea. Again, you'll see the CPU getting used here, but this is a fairly big machine. So once you get over that little mountain, that's also non-toxic. Okay, so I guess I can't come up with a toxic phrase. Maybe I'm too positive. All right, so I'm not going to worry about that. The accuracy, of course, of that process depends on the training set. So it depends what is in the training set and how it was flagged, and also what the use case is. So just because this model is showing certain accuracy, you still have to test it for the use case that you have. But anyway, the point is that you do have the ability to do that now inside Dotnet. You see, and I'm going to open here on the right side some of the things here. You see the analyzers here. NuGet is a way to add packages. And you can see that Microsoft.ml was the package added here, and then .NET Core, which will enable this console app to be deployed on multiple platforms. You saw earlier that that's including Linux. So this would be something that could be used for that purpose. Now let's run a second one here. So I'm going to close that program, and I'm going to go to the spam example. So that was the sentiment analysis. Okay, and this was more about reviews. Just describing this sentiment analysis first, you can see it here on the description, and again, this is in GitHub. So I'm in GitHub. It's showing what the problem is. The ML task is binary classification to classify items in one of two classes. And you have a build, train, evaluate, consume, and then it describes what building a model means, what training a model means, what evaluating, and that's when you have this evaluate command, and then consuming, which is prediction here, and then the trying the sample. So this example is just one of several that obviously are in here, and that's the sentiment analysis. Now I'm going to move to spam detection because I want to show this one, show at least two here. Spam detection for text messages. So the goal is to predict whether text message is spam, like irrelevant, unwanted messages. And we're going to use a spam collection data set for this purpose. Now, in this data set, they have 6,000 messages that have been classified as either being spam or ham, H-A-M, meaning not spam. So they just made up this, word ham just because it rhymes in English. And that just means that the message is not spam. So this is an example, again, of a binary classifier. We're classifying the text messages into one of two categories. So we're going to do that here. But as part of this, I also have a second poll. So I'm going to give you a chance to do this second poll. Okay, so now let me go and launch that. So now this poll is going to launch 4 phrases that you'll see there on the screen. And what I want you to do is click the one or multiple ones that to you look like spam, so that you understand what the goal is here of the of this task. So you see what we're trying to achieve. And again, we're only looking at short phrases. So you're going to see that the way this problem is set up, we're just basing it on like 1 or 2 sentences. I know that many people will look at actual spam messages and they're going to consider everything. They're going to consider where it came from, what the sender's email is, what time of day, and other thing, any metadata we have, and then images and whatever else is in the message. So there's a lot of markers beyond just simple phrases. But this simplified version of the problem is what we're focusing on. We're not focusing on the fact that it's not as rich as it could be. So I understand possible objections to using this approach, but nevertheless, we're going to go ahead and go with that. All right, so I'm going to go ahead and close the poll, and then I'm going to show the results. So you see the results there of what people thought was spam. And again, I'm going to completely say and agree with everybody that says, oh, all of them could be spam or all of them could not be spam in an actual real world case. So we have to factor that in, because the type of solutions that I build for enterprise customers, we're not just doing toy problems, but we are, trying to solve some, serious topics. So, granted that in the real world, any of those could actually be spam or not spam. But the way the audience answered today, indeed, the second and the fourth answer are how the source data set had shown this information. All right, so now let's go to the online example, and I'm going to go ahead and run that spam detection console app, and you see just as easy as what I just did. I just pressed run, and there we go. And then we have the process memory. We can see scoring on the right side. In fact, it's already done. So as you see, it took the 4 phrases that you just had in the poll, and it classified the first one as not spam, the second one as spam, the third one as not spam, and the fourth one as spam. And of course, all of these none of these phrases were in the training set. They're all tests, and so they're just something that someone put in as the answer. Now, having shown that, and we also had a chance to see the CPU used here and the diagnostic tools. Again, it says hit any key to finish, and I can type in any key and it doesn't do anything. So I have to press enter, and then I can actually press any key, which I could space bar, and then it's gone. So that is what that does. And what I want to show is the actual code, because I actually saw something interesting. I'll tell you what I found. Let's go back to the spam detector message. Now it said that we are doing a binary. This is an example of a binary classification. And then when I read the code, down here it says multi-class classification, and then it says binary classification in this one. This was the C sharp. And then I went in the F sharp, and this is supposed to be binary classification. And right here, this one says binary classification. But on my code, I was seeing multi-class classification, and then multi-class classification cross-validate. So I'm a bit skeptical that this is correct. And now as a data scientist, I don't know why we have binary classifiers, because to me, everything could be done in a multi-class classifier. But we, in some technologies, such as this one, we do have binary and we have multiple class. So I don't view this as a logical error, but possibly a physical error to do that way. So let me close this one. So this is the C# example here. It shows, again, very similar things where we're transforming, and then we build our model, and then we're testing it here for these messages. So you see the messages are hard-coded into this application just for the purpose of the demo. But I'm going to close that file, and I'm going to close the solution. I'm going to close this browser because I'm done with that. I'm going to go back to the repo, and I'm going to open up the other one. The other solution here is just for F#. So I'll give you all a chance to see F#. And go into the spam. Oh, actually, it's in a different order. Okay, so here it's up here. So this code now is F# code. Let me see if I can make it bigger. There's got to be a way to make it bigger, and oh, there it is, right there. All I had to do is scroll the mouse, and it made it bigger. So it does say binary classification, but then it also says multi-class. So again, I'm not sure if this is correct, but logically it should be okay. And that would be, one thing that I would wonder how this is built. So the point here is that I think in a very few lines, you can see that it is possible to have this process make a model and give the results. And by the way, I'm going to show now the assets that are produced. So let me go to users, me, source. Oh, actually, I made a shortcut and I forgot. I made a shortcut here under quick access. It goes straight to the area, but that's where we are. And then under F#, getting started, and we did the sentiment analysis first, and there's a solution. And what it will have here inside, well, first of all, the data. So there's a data set that you can look at, and then the ML models. Let's see. This folder is empty until you run the training console app and create and train the models as zip files. Okay, and I don't know that I actually did that because I don't see anything in there. So let me go to this one. Okay, I guess I didn't save it, but it would be saved in those folders. Let me go to F. Oh, you know what? I might have been in the wrong one. Let's see, C#. I think I was in the wrong one. Yeah, I was in the wrong one. So this is the sentiment model here with the compressed zip file that represents the, you know what, I'm going to open it because I'm curious. What's in here? Okay. So what is inside is in a format that ML.NET understands as a model. That's what's important. And if you want to, if you're the type of person I am, I will open things even if I have to look at hex code just to see what it produces. And right now I'm inside a zip file. So the important thing is that you have a file that represents the best model there, and that will be something that could be used for that purpose. Okay, so just mentioning again what's on this main screen in terms of examples. So we have some here for binary classification. We have some for multi-class classification. Just in running some of these, I found that some of them do take a little longer to run. And then we have some recommendation examples, and then regression. So the difference, but classification will put something into a group, and then regression will produce a number, like what is the price? How much sales are there? What is the number of, represents the demand. Multi-class is good for things, it could be used for a recommendation engine. Oh, actually, sorry. What I said is correct, because I didn't see that this was under a different header. But multi-class classification can be also used for building a recommendation engine. That is true. But separately, we have recommendation algorithms that are for that purpose. And then we also have clustering, such as customer segmentation. Anomaly detection is used when you have highly unbalanced sizes and you need to see like a small signal, for example, in a sales, or when seeing something that's very rare among something that's very common. Then we have some here for computer vision. So we have some TensorFlow and Onyx, which I'm not going to show. Oh, and also here, cross-cutting scenarios. So plenty of examples, lots of them in C#, F#, and providing you all with that information. Again, this presentation is the only one where I'm going to show those examples. Interestingly enough, we got 3 other ones, and I'm going to be showing demos that are not in this group. Okay, so we got other information that's coming. So let me go back to the main deck, and we are going to have a few, maybe an opportunity for you to ask questions if you want to do that. And I'll go ahead and pop out that box. Okay. Someone, and I'll start answering the questions now while I'm showing these slides. Let me go to this one. This is the guide for machine learning with F#. And if you go online and you look at fsharp.org, they will make the case for why F# is very cool for machine learning. And I've seen this case made in years past, and I am still on board that for a lot of the mathematical programming, F# is a very competitive answer for doing that. And there are examples and also a number of people talking about that. And also generally for math and statistics programming, you want to look at F#. And you really want to consider what is the advantage of programming in F#. And by the way, you can blend these into your C# solution. It's all .NET, so we'll compile. I didn't see any blended ones that way. But once you get your program assembled, you can blend the two technologies together. So consider that. Also, I want to mention here, as far as going forward, that there is such a thing as .NET for Apache Spark. I'm not talking about it today, but just know that distributed processing is a technology that you can start leveraging right now. And then the .NET architecture guide. So I did not talk about architecture, and separately from the .NET architecture is the Azure architecture guides. So there's a separate section of Azure architectures and how to blend these with other Azure technologies. But if you are certainly in the .NET world, the examples now that are on this website are of critical importance to actually putting a solution into production. So that is the important thing to know there. Now, let me start answering some of these questions. Someone told me about using Office Outlook, and I'll have to do that later. I may be able to get that before the next presentation. And the deck and the recording will be available, and you'll see that in an email where I'm going to send a follow-up email showing where that will be posted. The video, of course, will have to be uploaded to YouTube, so that's just a process that's going to take some time. There's a question here: does ML.NET support Keras? And the answer is I don't know. And what I would do is continue to track the technology. I did see TensorFlow, of course, already in there, and Keras would be of particular interest because it is obviously the way that many people are using Keras. So to my knowledge, no, but consider that we are early days right now for this technology. We have an active development team working on the technology, and then feel free to send in your questions. And by the way, let me open up a website here because let's see, going to our MLNet GitHub. There is a way for you to join the community, and they're using a technology called Gitter, Gitter, and this is from the GitHub place. So when I click there, you will see that there is a way for you to log on and talk to the people behind this technology about your questions on ML.NET. So feel free to go ahead and answer your Keras question in there, and in fact, go ahead and answer the question. Is it on the roadmap? I don't know what is and is not on the roadmap, but go ahead and ask. All right, starting with lowercase letters may be training to detect rather than what is intended. Okay, oh, that was just a comment. Okay, the deck again will be shared. Step 2 was to use a transformer on the input data. Step 3 was to build a model which creates another transformer. Oh, could you explain that use? Okay, that's a question I can quickly answer. And what they're referring to is in here, and that was a spam example. Again, I don't know if it's still, oh yeah, it is, it's still open. Okay, so here's what the question was. What this is doing is a two-part here. First part has to do with changing the variables, and the second part has to do with making the algorithm. And what ends up happening is everything gets appended together. So what happens, this data process pipeline right here gets appended to trainer, and what they did was they just broke it up into 2 steps, showing you that the first thing you want to do is all the data manipulations, and then the last thing you do is add the algorithm part for the model. And so that's why this is broken up into 2, and it's just done for demo purposes. In actual life, you could just take all this out and just do append, and then that's your training pipeline. So the whole thing will be the entire pipeline, which is 2 parts. One is the data part, and what's the training part. So that's just being able to see it with your eyes. But that's an important question in being able to see this. Can we do time series related prediction with ML1? I saw an announcement on that. I don't see the example for it to do that. So that is what I have on that question. How does it interoperate with Python-based libraries? Okay, great question. And you want to come tomorrow to my talk on Nimbus ML. It's going to be offered at the same time, and that's going to be Python with ML.NET. Does ML.NET support execution on GPUs? I don't know. Let me see. I don't know the answer to that question. The answer should be yes, but I wouldn't claim that unless I saw it here on the screen. And I think I don't have an answer for that. So I don't know the answer to that. So I would ask that question in Gitter and CUDA. So GPUs, CUDA, FPGAs, ask about that on Gitter. How about anomaly detection without any labels? Again, I don't know the answer to that. I do know labels are better to, it's better to do labels. And the reason is, even if there's an inference procedure to make labels, you'll have to trust the process that does the imputation. So as a data scientist, I always have a concern about any automated labeling technologies. Not meaning I wouldn't use them, but even if I did use them, that I would audit them and make sure that it's tracking in the way I want to do it. Okay, recording is not going to be, you're going to get an email about the recording. Can we use ML.NET for visualizations? Okay, so the answer would be yes if, now ML.NET is just a model producing engine. So it is not producing visualizations for you. However, if you do have the numbers that come out of it, like for example, if you were doing a regression, then you could use those numbers and put them into a visualization library. So that's what I would approach it. I'm going to tell you a lot of solutions that we do. If we're doing an Azure solution, we will often have Power BI as that visualizer. And a big reason is because Power BI Desktop is completely free and could be used just to, for as far as local use. And a lot of times when I'm working with data scientists, it is for development purpose. So it's not for a wider audience, and Power BI would be an excellent way to do that. By the way, now I'm coming up with a thought here because tomorrow I'm doing Python with Nimbus ML, and there is a Python way to work with Power BI, and that would be interesting to try to explore that as far as visualizations. Okay, do we have any support for ML.NET with Jupyter notebooks? And the answer to that, I did find let me see, oh, you know what, it'll click in. Okay, so I'm going to show you one thing I found on the web. This is F# and Jupyter. So this, I haven't used it, okay, but I did find it, and I thought, wow, that's interesting, and I was thinking even of using it for this presentation, but it's better right now just to stay at Visual Studio for the introduction. I don't know the answer for C#, but here's an answer for F#, and I would certainly explore that. Because it's available for F#, then you can also load the ML.NET, therefore you would be able to use that with the Jupyter. Can we also do data preparation activity in ML.NET? The answer is yes. There's only certain types of prep that are in there, but don't restrict yourself to that, because there are other ways also to manipulate data with .NET. That's not the focus of today's presentation. So the answer is yes, look to do that, but also caution, don't do that with something huge, because if it's a lot of data, then you would want to have that pre-processed before you get to your application. You want to do as much of the ETL as possible, and especially for large data sets, before you get to some sort of coding, whether it's .NET or some other language like R or Python. Okay, is there an R library for ML.NET? To my knowledge, no, but you know what? Keep watching. That's all I'm going to say. Keep watching for R. And can ML.NET use Python libraries? And I would use that with Nimbus ML, and we'll talk about that tomorrow, because that's how to use Python with ML.NET. Okay, and the person's talking about data prep. You mean like outlier detection and replacement of missing values? And the answer is yes. So here in the how-to guides, we got filtering data, replacing missing values, which is just what you said, using normalizers like min-max normalization, binning. Binning is very important. Categorical data, what might you need to do? Text data, some of the common things are in here. And go ahead and, again, I think product team is active on, at least the team behind the Gitter, it's got to be, the ones that are producing this. So feel free to ask them about other transforms that you may want to see that are not on this data prep list. Okay, we are coming up on the hour, and let me go back to the slides, because I want to show you how to get to the next presentation. If you're going to jump into the next presentation, which is not in this session, you're going to have to be in another section. So there's going to be a call to action slide. If you do that QR code, you will jump into the next session, because we're going to stop this one and we're going to be in the other one. So thanks everyone again for attending today. Our next session, we're going to be looking at AutoML with ML.NET. And then tomorrow, we're going to be looking at Nimbus ML, which is Python. And then the second session tomorrow on automated ML generally, and that's going to focus on Azure. So again, all different demos for each one. They're all unique, and they represent now a new explosion of technology in this area, providing help for data scientists. Thanks again for attending today's presentation.